Good afternoon, guys. Hello, everyone. Welcome to Maths online class of Anand Medical Academy. As we are discussing the chapter Relations and Functions, which is second chapter of your NCERT first PUC. In that already we have discussed the relation part. Before relation also order pair and Cartesian product we have discussed. And when it comes to relation is a subset of Cartesian product. Relation is a subset of Cartesian product. One thing you need to remember, Cartesian product is also a set, relation is also a set. So now from that relation, so what is the concept connected to functions? From that relations, what is the concept connected to functions? So let us discuss the topic of functions today. So before learning functions, so let us understand what you mean by function first. After that, different types of functions, what are the types of functions we will discuss in a next lecture. So when it comes to function, so function concept is very important in your class 11. Why? Because based on the concept of functions, so there will be a lot of linked topics in limits, in differentiation, continuity, integrals. So lot of topics based on the concept functions. So you need to listen very carefully. So before going into the function, so let us discuss some of the relations. From that relation can be called as a function. So those all things we will discuss now. So to describe that, I will consider two sets. Set A 1, 2, 3 and set B 4, 5, 6. So two examples I have taken, set A and set B, which is 1, 2, 3 and here 4, 5, 6. I will write some of the relations from this. See here relation from A tends to B always, right? Relation from A tends to B. What I will write now. So I will consider R1. That means in that one of the relation, that is order pair x comma y such that x nothing but y greater than x. Y greater than x where x belongs to A comma x belongs to B, right? What is this relation in terms of roster form? Order pairs x comma y we should write where x belongs to A, y belongs to B. Now y should be greater than x. So what type of order pairs we will get here? Can we write 1 comma 4? Can we write 1 comma 4 where y is greater than x, 4 is greater than 1 only. Next 1 comma 5, 1 comma 6. So 5 is greater than 1, 6 greater than 1 we can write. Now can I write 2 comma 4, 2 comma 5, 2 comma 6 and again 3 comma 4, 3 comma 5 and 3 comma 6. This is what relation R1. So I will give another relation, that is order pair x comma y. Order pair x comma y says that y equal to x plus 3. Y equal to x plus 3 where x belongs to A comma y belongs to B. For that relation write in roster form. So what are the x values we have? 1, 2, 3. If you substitute x equal to 1, what is y value? 4. Right? If you substitute x equal to 2, so it is 5. So if you substitute x equal to 3, what you will get? 3 comma 6. So this is another relation, and I will write relation number 3, that is order pair x comma y such that y equal to x plus 2. Y equal to x plus 2. Then x belongs to A comma y belongs to B. If it is x plus 2 condition, x plus 2. If you substitute 1, 1 plus 2, 3 is there? No. If you substitute 2, 2 plus 2, 4, yes. 2 comma 4. Next. If you substitute 3, 3 plus 2, 5, yes. It is 3 comma 5. If you substitute 4, 4 is not there. Okay. This is another relation. Now I will write relation number 4. That is order pairs x comma y such that y is less than x where x belongs to A comma y belongs to B. Y is less than x. Is any y value is less than x? Is 4 less than 1, 4 less than 2, 4 less than 3? No. So what we get is empty set. We know that empty set is subset to every set now. Empty set is subset to every set. That means empty set is subset to Cartesian product also now. So therefore this is also a one type of relation. So empty set is also a relation, right? So these are the four relations. Now what we will call, when we will call this relation as a function, right? First of all, relation means relation should be subset to Cartesian product. When tends to function means first it should be a relation. Relation means relation should be subset to Cartesian product. Now I will write definition of function. From that definition, you tell me which relation is a function, which relation is not. So that is, see, a relation f from set A to set B. Set A to set B is said to be a function. If condition. So that means a relation is also a function sometimes. That means a function is a relation. A relation f, generally relation will represent with capital R. But a relation f means in terms of function. A relation f from set A to set B is said to be a function if every element of A has one and only one image in set B. Then that relation will consider as function. Let us see once again. A relation f from set A to set B is said to be a function if every element of A, nothing but set A, every element of set A has one and only one image in set B. See, let us see. This is set A, guys. This is set B. Set A contains 1, 2, 3. Set B contains 4, 5, 6. Right? See, let us compare the relations. So, when we compare to relation 1, what is relation 1? 1, 4, 1, 5, 1, 6, and again 2, 4, 2, 5, 2, 6. Next 3, 4, 3, 5, and 3, 6. Is that relation, can we call it as a function? See, every element of set A has one and only one image in set B, right? I already told what are images, what are pre-images. The images which are linked to set A, these are images. So for this 4, 5, 6 are images of 1, 2, 3. So this 1, 2, 3 will call as pre-images of 4, 5, 6. Now every element of set A has one and only one image in set B. Every element of set A, for example, if we take 1 should have one and only one image. But how many images did 1 have? 4, 5, 6. So it is not a function. So this R1 is not a function. Did you understand? Next, R2, order pair x comma y equal to x plus 3. From this what we got? 1, 4, 2, 5, 3, 6. 1, 2, 3, 4, 5, 6. So what is the relation you tell? 1, 4, 2, 5, 3, 6. Now you see this definition. Every element of set A, we are talking about each and every element of set A has one and only one image. See, 1 is having only one image, 2 is having only one image, 3 is also having only one image. And also every element has an images now. So therefore this relation we will consider as a function from A tends to B. Did you understand now? When we will call a relation as a function, every element of set A has only one and only one image in set B. Then we will call function from A tends to B. Next, third relation you tell y equal to x plus 2. From that what we got? 2, 4, 3, 5. 2, 4, 3, 5. But what about 1? They said every element, but one is not there now. One doesn't have image. So here what we can write is one does not have any image. One does not have any image. Therefore, this relation is not a function. Right? Next, R4. Did we have any order pairs? Did we have any order pairs? No order pairs. No order pairs means no mappings. No mappings means no images. But every element of set A should have images now. So therefore, this is also not a function. These are relations. Why? Because these are subset to Cartesian product of A cross B. These are relations only. But these relations, when we will call as function, means every element of set A has one and only one image in set B. Right? Pause the video and note it down. Another definition in front of you. So one is a relation f from set A to set B is said to be function if every element of set A has one and only one image in set B. That is through relation concept. Now another relation we have, in another words, a relation R from A tends to B. A relation R from A tends to B is said to be a function. Is said to be a function if it satisfies two conditions. If it satisfies two conditions. One condition is domain should be equal to A. What is that? Domain should be equal to A. So we know that if these are two sets 1, 2, 3, 4, 5, 6. What is domain? Domain means in that relation set of all first elements we will consider as domain. Set of all first elements we will consider as domain. So that is one condition. Next, no two distinct order pairs have same first elements. No two distinct order pairs should have same elements. Like now we will check. So these four relations are functions or not. Is this first definition correct or not? Let us cross verification. Do cross verify through second definition. Now start with relation number 1. See what is the domain of this set. See already have told domain, range, codomain. So what is domain from this set of all first elements? 1, 2, 3. Right? Domain is 3. 1, 2, 3. Is the domain is equal to set A? Set 1, 2, 3. Right. So it is satisfying first condition. This relation satisfying first condition. That means is it a relation? No. It should satisfy both condition. What is second condition? No two distinct order pairs have same first elements. For example, if I consider 1, 4 and 1, 5. These are two different order pairs now. These are two different order pairs. Condition is no two distinct order pairs have same first elements, but these two are having same first element. What is that? 1. So therefore it is not a function. Right? Next one. Domain of this relation is 1, 2, 3. So which is equal to A. Right? And again next condition we will take. No two distinct order pairs have same first elements. If you take these two, no same first elements same. If you take these two, no first elements, common is not, same is not there. So this we will consider as a function. Right? Did you understand from those both definitions? So this is through relation, this is through concept of domain and order pairs. Next one. Relation 3 you check. 2, 4, 3, 5. What is domain? 2, 3 from this. Domain is 2, 3. But that is not equal to set A. Set A is having one element also. One element 1 also. So it is. So it said it doesn't satisfy first condition. So no need to check for second one. So it is not a function. Next third one. Empty set. Domain of this is empty set only. Domain of empty set is empty set only. So but that should be equal to A now. So it is not. So therefore it is not a function. And always remember that if it is 1, 4, 2, 5, 3, 6 from this second relation, function means not only like this, like straight arrows. Not only like straight arrows. For example, if it is mapped like this is 1, 2, 3, 4, 5, 6. 1 mapped to 6, 2 mapped to 4, 3 mapped to 5. This is also a function. Don't think that always it should be like a straight arrows. Not like that. Every element of set A having images or not, first you need to check. After that, each and every element having only one image or more images, that you need to check. So this is called a function.